Great. Well, thank you very much. And I think it's time now to move on to our next installer. We'll have an opportunity for more questions at the end. But Larry Lessard from Achieve Renewable Energy, and why don't I let you take it away?
Thanks, Susan. I'm Larry Lessard from Achieve Renewable Energy, as Susan just pointed out, and I'm going to provide an introduction to the use of ground source heat pumps. Advance the slide, thanks. I'm going to try to cover several topics, provide information on what geothermal or ground source heat pump heating and air conditioning is, how does the equipment work, what are the components of a system, identify some of the benefits of geothermal systems. And you will notice that I use ground source heat pump and geothermal interchangeably. That is typically what the general population does, so I try to mimic that. Then I'll talk a little bit about project pricing and operation, and then again have a few minutes for a question and answer. Ground source heat pumps can be configured a variety of ways with respect to the distribution system that distributes the heating and cooling throughout the home. Most ground source heat pump systems are ducted systems, providing both heating and cooling. Ground source heat pump installs are usually complete house heating and cooling systems, not so much a technology for just doing part of a home. Radiant flooring is very compatible with ground source heat pump. And we also have ductless options for ground source heat pumps, and can also have hybridized installations with some ducted and some ductless. Heating through baseboard can be done. It's not all that common because you can't do air conditioning through the baseboard, and most people want that capability. Old style steam radiators or high temperature radiators are very unlikely to be something that we would use in a distribution system. That'd be something new installed there. Next. So the first thing you need is a Volcano. And Jeremy, if you could advance. For ground source heat pump, we really don't need a Volcano. A lot of geothermal knowledge is based on science shows and segments on TV that show how things are done in Iceland, and that's not what we do. We exchange heat and cooling with the ground, and we benefit from having a moderate ground temperature that helps with that system. And here's how, it's okay, you can go on. The methodology for the exchange is shown here, where during the heating season, heat energy is extracted from the underground heat exchanger, here shown as a vertical closed loop, which is the most common. And then that fluid is returned to the ground to rewarm and then cycled again and again, each time providing heating to the house through the distribution system, which again is most commonly ducting, but other alternatives are available. In the cooling mode, heat energy from the house is pumped into the ground where it's absorbed. And that process allows the home to be cooled. Next. When operating our equipment, we're using electricity to run the equipment, but we're not using the electricity to create the heat. The heat is being harvested from the earth. And for Joe had mentioned coefficient of performance, COP. The COP for ground source heat pumps can reach 5 or even more. Please go back. So that 1 unit of electricity is used to harvest 4 units of energy. And with a ground source heat pump, the heat of running the equipment also ends up being put into the house. So with 1 unit of electricity, we can deliver 5 units of heat. Next. And here I want to introduced the concept of heating efficiency and also what you buy and what you lose and what you can get for free using different technologies. On the left, we see there's a pie chart that is all one color, and that represents an electric baseboard or electric hot water heater. And if you put a kilowatt of electrical energy into one of those devices, you'll get a kilowatt of thermal energy. So that would be 100% efficiency or a COP of 1. Now, electric heating, while efficient at the 100% level, is not necessarily the most economical way to heat your house. If you look to the right, we see a fossil fuel system, in this case fuel oil, and you have to purchase the entire pie, but a portion of it goes up the flue with the combustion gases. So in this case, there's a COP 0.78 boiler, a 78% efficient boiler. That's what you might have if your boiler was installed in the 1970s or early 1980s, and you're losing 22% of the energy up the flue, but you have to pay for the entire pie. With ground source, the situation is somewhat reversed from the fossil fuel system, where you're paying for the purple wedge so that you can harvest the energy in the green portion of the pie chart. Next slide. So I'll briefly show examples of the components of a geothermal system. Next. Here are some pictures of some ducted geothermal units. In the center, we have what we call packaged units. The bottom section of those center units has all the geothermal components in it, and that's put into the same box or packaged with the air handler, which is in that larger upper section. And these machines can support multiple heating and cooling zones, depending on the model line, up to 6 zones from one machine. On the far left is what we call an indoor split unit. That's just the geothermal components, and then refrigeration lines would connect to a remote air handler that might be located in the attic with the geothermal unit in the basement. On the extreme right is a ground source heat pump that makes heated and chilled water and can, in some cases, replace the functionality of a boiler. Next slide. The underground heat exchanger is very important. There are 4 types that are common in the United States. This first one shows a horizontal closed loop. That's popular in parts of the country where lot sizes are large and digging is easy. And neither of those are the case for most houses in Melrose. The second slide that's come up is a vertical closed loop, where we would do the same heat exchange, but do it vertically with those borings being installed with a drilling rig. There's no surface exposure of that drilling after we're done, and everything's backfilled. The third slide that came up shows an exchange with a pond. That's also popular in other parts of the country, very difficult to permit in Massachusetts with conservation requirements and most ponds being owned by municipalities, not the people with frontage. And then the final slide that came up is also a popular technique in the Northeast. It's a version of an open loop system called a standing column well, where groundwater is processed through the equipment and then returned to the well. And those are desirable in instances where people have another use for the water, so that the well can have a dual use. Perhaps someone does a lot of irrigation or needs to fill their pool, that sort of thing. Next slide. So there are a variety of benefits to the ground source heat pump installations, including them being a renewable energy source, very high efficiency for both heating and cooling, large operational savings from traditional systems, significantly reduced carbon footprint, the ability to eliminate fossil fuels and the associated combustion at your home. And then the equipment's all designed to be as environmentally friendly as possible, with ozone-friendly refrigerants and vinyl-free piping and all of that. Next slide. As Joe mentioned, there's special pricing for HeatSmart Melrose. We were all lucky enough to be selected from a competitive bidding process that included qualifications and experience as well as pricing. The pricing for ground source heat pump included 3 base system sizes. So there were specific houses described, and we had to provide pricing for 3 size homes that had these specific requirements. Water Furnace, the company's equipment we sell, has different model lines that have different efficiencies and different feature sets. And so for each of those 3 model lines, we bid the 3 different sizes so that people had a choice. There are also adders to these base systems that can add features and options, resulting in the project price going up or down, depending on the design and the feature selection. All of our base pricing and the adders are publicly available, so you can confirm that the pricing we give you matches the bid pricing. Most of our projects do include adders. People will want zoning or internet connectivity, or have additional requirements for heating and cooling capacity because of the size of the house. The prices that we have provided are below our standard market prices, and we do that because we can rely on there being marketing assistance from the HeatSmart team. This presentation this evening is one example, and hopefully a volume of projects in the one municipality where we get some economies of scale. Our proposal for HeatSmart included special pricing on our labor, special pricing from the manufacturer on the equipment, special pricing from the drilling and excavation firm, and special pricing on the wiring. And there are a lot of incentives for ground source heat pump, more than most any other technology. And here's just an example. If we had a project that had a pre-incentive base price plus adders of $60,000, which is more than many projects in Melrose would be, but I like to work with round numbers, so I picked that for the example. There's a federal tax credit equivalent to 26% of the project cost, so that has a value of over $15,000. Currently, the Mass Clean Energy Center has a grant program that will eventually run out of money, but their average award under that grant program is about $8,500, so that's shown here. And then you earn alternative energy credits, which are electronic certificates that ultimately the utilities purchase. And how many you get depends on the size of your house, and the value depends on open market pricing. And just as an example, we put $3,000 here. So the net cost of that $60,000 system is reduced almost in half by the incentives. Next slide. And this is a slide Water Furnace put together. They customized it for us based on electrical and fuel costs in our area. And it shows the cost per million BTUs of running a system, with propane being the highest shown. Electric resistance is in that same range. Fuel oil and then air source heat pump are shown, and then even ground source is even cheaper than natural gas to operate. Next slide. Carbon dioxide or greenhouse gas emissions are also the lowest for ground source heat pump compared to the fossil fuel alternatives and electric resistance heating, substantially less than most of the fossil fuels, and even 30% or more less than natural gas. And as Joe pointed out, that's with the current electric grid. As the grid gets greener, the differential becomes greater. So in summary, ground source heat pump or geothermal systems provide comfort and savings. They're very reliable. They reduce your greenhouse gas emissions. They're safer because you can eliminate fossil fuel use and avoid fuel spills or carbon monoxide risk. The equipment's very quiet and it lasts longer than conventional equipment, and all of that provides peace of mind. With that, if there are any questions, I could address them now.
I'm going to ask you a couple of questions that I had emailed to me. I'm not sure the person who emailed me is able to be on here today, but one was from someone who has radiators and doesn't really want to put in ductwork and wanted to know whether a ground source heat pump is a possibility in that situation. Are there ductless versions, and what does it look like?
Directly supplying radiators with a ground source heat pump system can only be done under special circumstances where the house is substantially more efficient than when it was originally built. But ductless options absolutely are available. And those ductless units, the condenser unit remains in the basement, so you don't have anything visible on the outside of the house. And the head units can be similar to those that people might have seen with a mini split system, like the equipment that Joe installs. And there are also ceiling cassette and floor cassette options and console units that are available for ground source as well as air source systems. So there are good solutions that are ductless.
And another question that I'm just going to ask, because I get it all the time, is the specific things about Melrose that might affect ground source heat pump, in particular, sort of how ledgy it is here, and is that an issue for drilling for ground source heat pumps?
Yeah, that's a common question, and the answer is somewhat counterintuitive. We prefer shallow bedrock. The drilling rigs are designed to drill through bedrock, and they move through bedrock quicker and less expensively than they do through soil. The reason for that is when they're drilling through soils, they need to set a steel casing to stop the hole from collapsing on itself. And that casing is sacrificed to the hole. And that steel, especially now with tariffs in place, can almost double the cost per foot. So if we had a site where it was only 4 or 5 feet to rock, that would be, in our mind, perfect.